Hello everyone, I'm Paul and today we're solving problem 342, power of 4. This is an easy one, so here I will show you my intuition, approach and an efficient solution. We are given an integer and we need to return true if it's a power of 4, else we return false. So for example, if n is 16, we return true because this is a power of 4 and more specifically this is 4 to the power of 2. If n is 5, for example, we return false because this is not a power of 4. Now let's say n is 16 again. How can we solve this? Well, first let's see what is the base 4 representation of this number. We know this is the base 10 representation. And here we have the base 4 representation of 16. We go from right to left and we do 4 to the power of the current position. We start from 0. So next we have 4 to the power of 1 and 4 to the power of 2. And I know this is a power of 4 because we have a 1 in the leftmost position and then every other number is a 0. So if we see this pattern in the base 4 representation of n, we know that this is a power of 4, so we just return true. Now there are many ways to solve this. We could iterate every position, for example, and check if after this entire iteration we have only 1 1 and then every other number is 0, and if so, this means we have the pattern we are looking for, meaning this is a power of 4. Or we can take a different approach. We can have a value, we'll say this is current and this is initially 1, meaning we start here, 4 to the power of 0 is 1. And now we are checking if this is equal to n, and in this case it's smaller. And while this is smaller or equal to n, we just continue. So now we are trying this base 4 number. So we just take 1 times 4, and this is 4. So now we are checking if 4 is equal to n. In this case it isn't, and it's smaller than n, so we continue with the next power of 4. We have already tried 4 to the power of 0 and 4 to the power of 1. Now we are trying 4 to the power of 2. So we take this value times 4, and this is how we get 4 to the power of 2. And this is 16. So now this current value is equal to n, meaning we can just return true here. If n is 15, for example, and we reach this point where current is 16, well, here we just return false because 16 is greater than 15. So this is just one simple way to solve this, but remember there are many different solutions. Time complexity for this will be big O of log n, and space complexity will be big O of 1. So now let's go with the code and hopefully you will get the idea. This is a short code. First we say current is 1. Remember this is 4 to the power of 0. And now we say while current is smaller or equal to n, we are iterating every power of 4 that's smaller or equal to n. So if at any point current is equal to n, we just return true. And every time we say current times equal 4, and this is how we move to the next power of 4. And if we end this loop and we never return true, we just return false. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.